Today we're going to take a look at function notation and graphing nonlinear functions. So function notation is that notation of f of x or g of x, h of x, any sort of lettering system, but it's just of x. So some letter of x. So when we're asking the question f of -2, we're wondering when x is equal to -2, what is the output that we get for the y value? Because in a function, each x value has exactly one output of a y value. When you take an x value and you plug it into a function, you get exactly one y value. So whenever you take an x value, you plug it into a function, you get exactly one y value. So in this graph, we have a graph here. It's asking find f of -2, find f of -1, meaning when I take x of -2, what is that output of the y value? So let's take a look at the graph over here. The x value of -2. So we're along the x-axis here, looking for -2. And -2 is right here. So on this graph here, this parabola, we're wondering when x is equal to -2. So when I'm here at the x value of -2, what is that y value that corresponds? Right there. So when I'm at the x value of -2, I am at the y value. This graph exists at the y value of -2. So f of -2 is equal to -2, because this y value right here. Maybe I'll change colors here. Maybe try that. So when x is equal to -2, I'm looking at this parabola here, and I'm wondering what is the y value that corresponds to that x value of -2, which is right here, this y value of -2. So they kind of match up right there. Let's look at f of -1. So f of -1 is when the x value of -1, when we plug in the x value of -1, what is the y value that we get back? So here's the x value. We plug x value into the function. We get back this y value, also -1. That point right there crosses right there. So when x is equal to -1, we're right there at -1. So technically, this ordered pair would be -2, -2. This ordered pair would be -1, -1. Kind of weird example that we're getting like the same output as the input, but you know that's going to happen sometimes. Doesn't mean it's a weird, like rare question or anything like that. It's just going to happen sometimes. So now number 2, find all the values of x such that f of x equals -5. So in this question, we're asking, well, when we plug in what x values, meaning what x values are going to result in the y value of -5. So what x values are resulting in this y value of -5. Sorry if I just hit the microphone. I don't know if that was loud on your end. But that's what we're wondering right now. So it could be multiple x values, because multiple x values can go to the same y value, but an x value cannot go to multiple y values. So it's okay if like 100 x values go to the single y value of -5. That's fine. But we just can't have one x value go to 100 different y values. So let's see in this example if what's happening here. So I'm looking at the y value of -5 right here, and this red parabola that's going like this. I want to know what x values will I plug in that will give me back this y value. So if I'm at x equals, let's just say -2.5 right here. So -2.5. What is the y value that I would get back? Y equals -2.5 would fall, I don't know, somewhere around here. So like somewhere between 3 and 4. I just picked up space at random. But you see how that's not y value of -5? It's not. It's like -3 point something, somewhere between -3 and -4. So that's what I'm looking for. I'm looking for, though, when y is equal to -5. So I'm looking at this space right here, boom. This space right here, boom. So I'm hitting the parabola at this point, So what are the x values that correspond to that contact right there? X equals -3. And x equals +1. See right here. So I'm just looking at the x value here of 1. Looking at the x value of -3 right there. So when x equals to -3, I get back the y value of -5. X equals -3, I get back to the y value of 5. And when x is equal to +1, I get the y value of -5. So there are 2 spots that result in a y value of -5. Next, we're going to look at square roots, and we want to look at square roots because we're going to be graphing nonlinear functions in a minute here. And nonlinear functions could take the form of a square root of an x value, or an x value being squared, or cubed, or some sort of root of an x value. So square roots are numbers times itself. That gets you back that number. So for example, like 3 times 3 is 9. So the square root of 9 is 3. We're just looking at principal square roots, because I know you think like, well, negative 3 times negative 3 is also 9. So we could have like a plus minus. Yes, but we're not really looking at an equation aspect. We're just looking at the principal square root. So we're just going to say like the square root of 16, what times what gets us back to 16, or gets us to 16. That would be 4. So the square root of 16 is 4. And you can take square roots on your TI-30. So if I have my TI-30 here, and it's pretty easy. If you have a TI-30, I'm just going to write down the steps real fast. To take the square root of something, you just hit the second key, and then you hit the x squared key, because the reason I'm hitting that key is because right above it I have that square root symbol, and so I hit second, meaning I'm accessing the operations above each key. And then I hit second square root, and then whatever I'm typing in, so like 16, just type 16, hit equals, and then you should get back 4. 4 times 4 is 16. And obviously you don't need to use the calculator for all these, but just good to know. Square root of 121, that's going to be 11. 11 times 11 is 121. We're talking about principal square roots here. Number 5, square root of 1 over 9. Whenever we're taking the square root of a fraction, we could take the square root of the top divided by the square root of the bottom. So the square root of the top is the square root of 1. 1 times 1 is 1, so it's 1. And then square root of 9 is 3, because 3 times 3 is 9. So the principal square root there would be 1/3. Big difference here between number 6 and number 7. Where in number 6 we have the negative square root of 49, and then number 7 we have the square root of negative 49. So the placement of the negative is key, where on 6 the negative is on the outside. So if I'm taking the square root of 49, I'm multiplying that result by -1, essentially. This is pretty much -1 times the square root of 49. So the square root of 49 is 7, because 7 times 7 is 49, but then I have this negative on the outside of the square root, so it would be -7. It would be -1 times 7, which is -7. Where on the problem sum number 7, I have the square root of -49. Square root of -49, I can't do, because there is no number squared, or a number times itself, that gets you back to -49, because it's all going to be positive or 0. 0 times 0 is 0. It's not necessarily positive, so I can't necessarily say it's all going to be positive, but it's not going to be negative. So in this case, it's not a real number. Not a real number, so it's getting into the different number system, the non-real number system, which is for later on, but for right now, square root of -49 is not a real number. And then the square root of 0, 0 times 0, as I already kind of mentioned, is 0. Graphing nonlinear functions. So graphing, and if you plugged in, going back to this square root real quick, of the negative, if you plugged in into your calculator second square root -49, my exact result, let me see what mine says. I think it's like non-real number. It says domain error in my calculator. Some calculators will say like non-real number or some sort of error message, but you can't take the square root of a negative. In the real number system, at least. Okay, graphing nonlinear functions. So graphing a nonlinear function, it's really important to understand what you want to graph here. So graphing a nonlinear function, you want to get an idea of what's happening around this entire function and what x values will result in what the graph will look like. So when I'm taking 2x squared, I want to get an idea of what's happening on the negative side of the y-axis. So what's happening over here. Then I want to get an idea of what's happening over here on the positive side of the y-axis. So on the positive axis, the negative axis. So I want to get a good idea of what's happening all around. And once you do a couple problems, you'll get an understanding of what graphs will look like based on what the function is. So this function is 2x squared. So I'm going to take some x values. I'm going to take -2, -1, 0, 1, and 2. So I'm just going to take -2, plug it into the function. So it's going to be 2, and then -2 squared. I would just use the calculator. You could do the same thing for the TI-30. to square a number, I would do this like exponent. Or you could type it all in once. So I would just type in like 2, and then I would hit the left parentheses, and then I would type in -2, right parentheses, and then I'd square that value by hitting the caret key. Not that. I hit the caret key, raise that second, and then it should hopefully do that okay. So 2 parentheses, -2. And you can just hit the squared key. There's a squared key, there's a caret key, there's multiple ways of doing this. But at the end of the day, no matter how you do it, you should get 8, because -2 squared is -2 times -2, which is +4. +4 times 2 is 8. So I did this first, -2 times -2, because it's squared. +4, +4 times 2 is 8. Or you can just do it in your calculator. We're doing -1, so 2 times -1 squared. -1 squared is +1. -1 times -1 is 1. 1 times 2 is 2. This first ordered pair would be -2, 8, which we'll just graph them all at once. Let's just grab these ordered pairs, -1, 2. Plugging in 0, 2 times 0 squared. 0 squared is 0. 0 times 0. 0 times 2 is 0. So it's just going to be 0, 0. Plugging in x equal to 1. So 2 times 1 squared. 1 squared is 1. 1 times 1 is 1. 1 times 2 is 2. So 1, 2. And 2. So x equal to 2. So 2 times 2 squared. 2 squared is 2 times 2, which is 4. 4 times 2 is 8. So we get 2 8s. Let's plot these points real quick. So -2 8 right here. -1 2 right here. 0 0. 1 2 and 2 8. So what's happening with this is going to go down, and then it's just going to curve back up. This is called a parabola. It's going to go down, it's going to curve back up, and go back up the other way. And what you got to understand here is what it's not doing. Let me erase this line real quick. What it's not doing is this. It's not coming straight in and then cornering and going back out. So it's not just like a linear, like a line, and then another line going back up. It's not doing that. It's a parabola, so it's going in, and then it's curving. I kind of missed there. It's curving back out. It's hard to show that curvature there, but it is curving in. Because what you want to understand with this is that each value is being squared. So like when I'm at the fraction of 1/2, it's not just going to be exact symmetry. It's going to be 1/2 times 1/2, and then that's going to be multiplied by 2, and then same thing here, 1/4 times 1/4, or 1/8 times 1/8. Like those values are going to be just changing. There's going to be some, if I like zoom this in a little bit, there's going to be just like a little bit of some curvature there, like as it comes around at that point. But that's why you want to grab a couple x values on the negative side, a couple x values on the positive side, because if I don't graph like this side, let's say I just completely didn't do any negative values. That's what I think the graph looks like without the negative side. That's not accurate because I have this other side that we need to see. So that's why I want to grab a couple negatives, a couple positives, and get a full understanding of what this graph is going to do. And understand that this is just going to go on for infinity up towards this way. This is going to go on for infinity as we go out to the right, as we go out to the left. Like that's just going to keep going. But the main component there is that middle value there where it's going to bottom out and reach a low point. So it's going to go down and then back up, and then you're good to understand the rest of that. Okay, let's look at the next one. So here we have -2 times the absolute value of x. So remember, absolute value of x. And this is -2 times the absolute value of x. So let's take some x values. Same thing. It's always good to just grab a couple negatives, grab a couple positives. 0 is always good too, unless there's some sort of like problem that could exist. But we'll talk about that later. So -2, -1. Let's take 0, 1, and 2. So taking the x value of -2, I get -2 times the absolute value of -2. The absolute value of -2 is 2. 2 times -2 is -4. It's always good to double check. Again, absolute value of -2 is 2. 2 times -2 is -4. And then we have -2 times the absolute value of -1. The absolute value of negative 1 is 1. 1 times negative 2 is negative 2. Negative 2 times the absolute value of 0. The absolute value of 0 is 0. 0 times negative 2 is 0. Negative 2 times the absolute value of 1. Negative 2 times the absolute value of 1. Absolute value of 1 is 1. 1 times negative 2 is negative 2. And negative 2 times the absolute value of 2. Absolute value of 2 is 2. 2 times negative 2 is negative 4. So we get a couple ordered pairs here. Let's write these down. Negative 2, negative 4. Negative 1, negative 2. 0, 0. 1, negative 2, and 2, negative 4. So we have negative 2, negative 4, negative 1, negative 2, 0, 0, 1, negative 2, and 2, negative 4. So this is the absolute value graph, absolute value. So this is not a parabola, so it's not going to curve in. What this is going to look like is this is going to be just a direct line, boom, and a direct line out. So a direct line in, a direct line out. It is going to make that V. It's going to make a corner. It's going to just be exact symmetry of boom, and then bam, like it's just going to go directly in, directly out, and meet at like a corner. Because it's just talking about absolute value. Like when I take the absolute value of 1/2, I get back the absolute value of 1/2. When I take the absolute value of 1/9, I get back the absolute value of 1/9. So there is just going to be that direct 1-for-1 type of symmetry, where before, going back to this real fast, when I take x squared, 1/2 squared is not just 1/2. It's 1/4, as I already mentioned a second ago. So we're not getting like the same, like just that just stair almost approach to it, where absolute value is just in and then back out. So that's what that would look like. And again, grabbing a couple negatives, grabbing a couple positives gives you that full idea. If I don't grab negatives, this is what I think the graph might look like. And that's, again, not accurate, because that is what the absolute value function looks like. There's that mirror image of itself along that top part here, or it meets that top and then it just goes back down. The next two is graphing the square root function. So the first one is graphing square root of x minus 2. And then the second one is the square root of x plus 1. So the x plus 1 is inside the square root. So this is where you're really going to have to test your knowledge of square roots to make sure you're graphing this accurately. So if I'm taking the square root of x minus 2, that minus 2 is on the outside of the square root of x. First of all, think of a starting point for the graph of the square root of x. If I just had the square root of x, let's just pretend I was graphing the square root of x. What x values could I plug in to the square root of x? Could I plug in negative x values? No, I could not. Like, I can't take the square root of -1, as we talked about with the principal square root. We did an example, I think it was like negative 49. Could not take the square root of a negative. So I can't take any sort of negatives. Like, so this space right now, in just like the base square root of x function, it's off limits. I cannot take the square root of a negative number, so I don't have anything on that side of the graph. So we have to start at 0, because the square root of 0 is 0. So now going back to our example here of square root of x minus 2. So I'm going to start at 0. So I have the square root of 0 minus 2. Square root of 0 is 0. 0 minus 2 is negative 2. What's my next x value that I could take? Let me fix that 0. What's my next x value that I could take? X is equal to 1. So the x value of 1, so that's going to be square root of 1 minus 2. Square root of 1 is 1. 1 minus 2 is negative 1. Should I take x equal to 2 for my next one? Think about that for a second. If I take the square root of 2, that's going to be a decimal. Whatever that comes out to be, it's going to be a decimal. I don't want to use that. I want to use the next best thing. I want to use a perfect square. So what's my next value? Should I use 3? Still no, because the square root of 3 is some rough decimal. Let's go to 4. Square root of 4 minus 2. So the square root of 4 is 2. 2 minus 2 is 0. And let's grab one more. So what would be my next one? Hopefully now it's starting to click a little bit. We're going to go to 9. So it's going to be a square root of 9 minus 2. Square root of 9 is 3. 3 minus 2 is 1. So we have some order pairs. 0, negative 2. 1, negative 1. 4, 0, and 9, 1. So 0, negative 2 is right here. 1, negative 1 is here. 4, 0 is here, and 9, 1 is here. Look how that is kind of looking. It's not just a line coming out. It has a little bit, let me zoom this in, has a little bit of some curvature. It starts here, and then it's curving, and what's going to end up happening, if you think about this just from like a logical standpoint, the square root of 9 was 3, so I know we're like shifted down a little bit, like the starting point would be like here, 0, 0 would be here if we were just looking at the square root of x. But what's going to happen is this is just going to, let me try to erase that, come on, erase, there it goes. It's just going to keep going on forever and ever, but it's going to be pretty flat as it goes out towards this way. Like it's not going to just explode to the positive y's or anything like that. It's just going to very slowly, gradually go that way. Because if you think about it, like the next value, if the square root of 9 right here is 3, and I know we have this shift here of the minus 2 here, so that's why it's not exactly at 3. But you get the idea of like when I plug in the x value of 9, I get 3, and then when I plug in the next one, which is 16, I get 4. The next one is 25, I get 5. Like it's going to be very, very slow, gradual increase through there. So that's what the square root of x minus 2 graph will look like. It's just that square root of x, and then all of those values are being subtracted by 2. So now the difference, though, between that last one and number 12 is on this one, I have the x plus 1 inside the square root. So inside the square root, that's going to be really important to understand that we have it inside the square root. So think of a starting point here for this one. First of all, just the square root of x, base function, square root of a negative 1 can't do. But think about what's happening with the value that we plug in for x before we take the square root. Whatever that x value we plug in, it's being it's adding 1 to that x value. So for example, if I take x equal to 0, what happens? I get 0 plus 1 on the inside of the square root. 0 plus 1 is 1. So really, I'm taking the square root of 1, which is 1. So my first order pair that I just generated is 0, 1. So 0, 1 is right here. But think about it. I don't have the square root of 0. I haven't done that. So how do I get the square root of 0? So meaning what x value could I plug in still? I could do negative 1. Because if you think about it, the square root of negative 1 plus 1, negative 1 plus 1 is 0. Square root of 0 is 0. So then now we have that starting point of 0. And I can't go further than that. Like if I take x value equals the negative 2, look what I'll get. I'll get the square root of negative 2 plus 1. Negative 2 plus 1 is negative 1. I cannot do that. So I can't take x equal to negative 2, but I could use x equal to negative 1. And that's negative 1, 0. That's going to be my starting point. And then we'll just grab like maybe one more. So that's 0 we already did. Can we do 1? Can I take x equal to 1? What's going to happen? 1 plus 1 is 2. Square root of 2, that's going to be a decimal. Don't want to do that. So what will be my next one? I want it to be the square root of 4. So what x value should I choose? X equal to 3. So 3 plus 1 is 4. Square root of 4 is 2. So I get 3, 2. And let's just do one more. So again, I want the square root of 9. So what x value should I use to get to the 9? Maybe 8. So the square root of 8 plus 1 is 9. Square root of 9 is 3. So I get the order pair 8, 3. And it'd be the same exact thing, just moved a little bit differently. So this time it was shifted over a little bit this way because that plus 1 was on the inside of the radical. Okay, so that was graphing nonlinear functions, and there's a lot of different looks that could happen, but just to keep this video under a certain amount of time, I'll just do those two examples. So one where you had the square root of x, and then that operation was on the outside of the radical, and then one with the square root of x, but the operation was on the inside of the radical, and how that changes things.